Hey guys, welcome. So by the end of this video, your game will be slightly worse on the surface in that you won't be able to move, but a lot better behind the scenes because we're going to be centralizing the code that deals with displaying how the cursor should show in these instances and what happens when you actually click. So we're going to end up with a much more robust camera raycaster. We're going to rip out our old camera raycaster, move away from enum-based layers, and use a custom editor script, although we're not going to explain how that works in this video, to set the layers so that layers are just in one place now. There's just a list of layers, and that's it in the layer editor. So it's going to be much simpler, much more expandable, but it'll be a little bit of pain while we just switch over to a new system. It'll be a meaty challenge in this video for you. Just before I get into the limitations of our current architecture, I want to tweak a couple of things. Firstly, our enemies are too small. They're scaled down, and I'm not sure that they need to be for the moment. So I'm going to, and also the animators don't really like scaling. So I'm going to take my enemy prefab and scale it to 1, 1, 1. Now, with prefabs, when you do this at runtime, we should find that the instances stay the same because they have already been instantiated from the prefab. But when I stop playing, the prefab actually keeps its changes because it's an asset, not an instance. And then when I play the game again, they're instantiated from the prefab with a 1-1-1 scale. All right, that's one thing. They all now have that. Now, the next thing is their UI bars are busted right now. And remember that the way that the place they get that is this enemy canvas health bar object, and it's missing its texture. And that was simply because of the PSD meta files from before. So I'll give it that health bar. The final thing is the health bars aren't actually facing the camera properly. They're very skewy. Look at these things. They're all over the shop, these health bars. So the solution to that is to go into the enemy UI code, and in my late update, I've got two different bits of code trying to get the transform of the enemy UI to face the camera, and I don't need both of them. I'm going to get rid of the line that is highlighted, and that should immediately that I save, even if the game's running, you should suddenly see these two snap towards us. That's much better. Quite hard to see their green health bars against the green ground, but I'm sure Rick will be sorting that out for us. I'm trying to stay focused on the behavior here. All right, awesome. So that's that bit. Now, the limitations of our current architecture is what we're going to start by talking about. And the problem we have right now is that if I've got two things I'm worried about. Number one is that I'm handling the change in cursor and the click in two completely different places. And I'm worried that as we get more layers, that we won't be consistently handling what the cursor is doing. So for instance, I could come in and decide to put myself, let's do it actually. I could decide to duplicate this block here, and let's just take a copy, Control D, move another one maybe here. Now, if I make this duplicated block a different color, like maybe white, something like that. Now, I need to be a bit careful how I do that. So I'm going to go and find a material, or let's actually just make a new material. It doesn't really matter, because if I change the material, obviously, then it's going to change on all the enemies. I'm going to call this a white stiff. A stiff as in a dead person. And we're going to apply that to that block. And I'm going to set this block to a different layer. In fact, I'm going to add a new layer just to start putting pressure on the system. Rick might well come along and say, well, we want dead bodies. So there's one. And we've made a layer called stiff. Now, there's lots of problems now. I've made a layer called stiff. If I assign this block to stiff, that's fine. Change all its children. But things aren't great, because I also have then got to go and change that in my utility class. I'd have to add this other layer. Also, the camera raycaster in here, if I choose try and add another thing to this list won't populate because it's populating out of an enum. There's too many things in too many different places. And also, on top of that, I don't know how the cursor is going to handle this stiff business. It doesn't know how to handle it right now. By the way, the little flickering you see on the top there, that white, that's called Z fighting. It's because the renderer doesn't know which of these two triangles that are at exactly the same position to render. So if I just move that up a tiny bit, it would solve that Z fighting. But I want to be able to add stiff to the layer priorities in one easy fell swoop, and then I want it to actually here, because there's no case statement for stiffs over the ground. I would want it when it's over this, when my mouse is here, over the stiff over the ground, I'd want it to go question mark. I don't know how to deal with that. But when we have stiff over enemy over ground, then it should know how to deal with it, because enemy would be higher priority, for example. We can't do any of that at the moment because there's no easy way to add a new layer. Other things are that the player is not pathfinding, and I think we should change our mind on that decision. When I click on an enemy, I don't get a game object coming back. I've got no event that tells me what I've clicked on, so I can't pathfind to an enemy in a similar way the enemy pathfinds to us. Generally, the architecture has got a little bit difficult, and it's time to start improving it. So let's import a new camera raycaster.cs, and it'll come with an editor script. So I've supplied that with you as a downloadable resource, and it's available as part of this camera and cursor Unity package. So import that, but don't import everything when you do so. It's got all sorts in it. It's got some slight changes to a lot of different things. We are going to get used to, when we import a package, not blindly taking everything. Let's decide that we're just going to take, for the moment, the camera raycaster.cs and the camera raycaster editor.cs. Now, don't worry what the editor script is and the fact that's in an editor folder. We'll deal with that in another video because that's a whole new can of worms. But the important thing is we're going to swap out the camera raycaster and then try and fix it. And I'm going to show, because it won't work immediately. So let's swap it out. Now, when we do that, it's going to start complaining about some differences. So what I want to do now is just walk you through what the changes are to this camera raycaster.cs and why we're making them. All right, before we then challenge you to go ahead and fix everything and get it working. So what's new about this camera raycaster? Well, actually quite a lot. There's a few salient things. Let me show you. So we still provide a list of layer priorities as an array to the camera raycaster. So there is the camera raycaster here. Here it is. But it's actually going to be an array of integers moving forward, all right? And we're going to start dealing with layers as integers, and we're going to get rid of that layer type. Then we have very similar things up here, but this is the whole new architecture. Instead of having those getters that we used to have for the positions and things, we've got a whole new delegate system here. It is on click priority layer. So if you click on a priority layer, then a load of observers, including, for example, the player to know where to move to, can subscribe to that and can respond to it, all right? So that's the big difference there. Then the rest of the changes are relatively simple. It's just a question of saying, well, you know, if the pointer is over a game object, then notify the, sorry, let me back up. This bit here is a little bit different. This is saying we have to special case if the pointer is over an interactable UI element. So we're going to need something new in our game and in all scenes called an event system. So if you go to game object UI event system, add that in, also put it in your prefabs, also tag it with scene setup. And what that does is it allows us to change properties of this event system if we like. And the event system processes UI input. Because remember that in the game we have this UI. And that's the first thing we need to check for in the Raycaster is, am I over a UI? This is what this is saying. Event system current is pointer over game object. By game object, it means a UI game object like this health bar. If I'm over UI, notify observers that the layer has changed to layer number 5. Now that's a magic number, and as part of the challenge, I'm going to ask you to remove these magic numbers and parameterize them into parameters. All right. Then it raycasts to the max depth every frame as things can move under the mouse. Remember that if the player's moving around, and you don't move the mouse, that the actual mouse is moving over the screen, even though it's not moving relative to the player. So we do need to raycast every frame, but we're now getting an array of raycast hits back. We're doing a single raycast every frame and getting a list of hits back. Then we're saying, well, if we got a raycast hit back, then call it priority hit and go and find the top priority hit for the list of hits that we had. So of the list of things that we found when we raycast through the world to the max depth, go find out what the top priority one was. If there is a top priority hit, then if there is not a top priority hit, notify observers that the layer changed to 0, i.e. the default. So we send default layer if we don't hit a priority layer. And return, leave the function, notice the returns here and here. Otherwise, we notify the delegates of a layer change. So the layer hit becomes the priority hit's value. It looks through the collider and the game object to the layer. Now, if you want, you can look up Demeter's law, and that will suggest that we probably shouldn't be doing this many dots in one go, but it's getting the job done at the moment. But if you do want to look up Demeter's law, I'll just find you a link to that. Demeter's law. Here you go. Law of Demeter. Have a look at that on Wikipedia and it'll explain why we don't want to be having too many dots like that. It's generally a code smell, but we're going to leave it there as long as you're aware of it. Notify, and I'll put this in your links, by the way, notify the observers of that new layer, and that's that. Now, we also, if the mouse is clicked, in the Raycaster, we're going to be asking if the mouse button is clicked, then notify the observers. So we don't need to be asking the question in the player movement anymore. In fact, for now, I'm going to boldly delete everything under fixed update in the player movement. And player movement will no longer work by the end of this video. We're going to focus just on getting the Raycasting working again with this new system. All right, and then we have a couple of methods. This is the method that does the notify observer if the layer has changed, i.e. if the layer has changed, then you set the top priority last frame to the new layer and you notify people of the new layer. And then this was just this roughly the same method we had before. All right, now that's a lot of code and a lot of changes, but the real way for you to get a feel for it is to go ahead and get your hands on it yourself. But before we do that, we're going to remove our layer.cs script as well from the utilities. In fact, that's the entire, it's not layer.cs, rather it is the entire utility script. We're going to remove the layer enum. Okay, because we're not going to be referencing these layers in so many different places. What we're going to end up having is a camera Raycaster sitting against the camera. We're going to be using something called an editor script, which will start working when our code compiles, and I'll explain that in another video, to pick from the existing list of layers without having to update anything. And then we're going to be dealing with integers for layers, and you'll see how that works when you get your grubby mitts on this code with any luck. So now you're going to have a ton of compile errors because we've got rid of the layer type, we've done all sorts of things, and that's what I would like you to sort out. I want you to get cursor affordance working again. So resolve all the compile errors, switch to integer-based layers, parameterize them though, don't use magic numbers. Expose layers in cursor affordance.cs. So what I mean by that is when you parameterize your layers, in your cursor affordance, we are using magic numbers in here. We're saying layer.walkable. If we've got rid of the layer type, these need to be integers. If they're integers, they're magic numbers, so make them parameters so that you say against your cursor affordance game object, you explicitly tell it which layer is walkable, etc. as an integer at the moment, and later we can do something called an editor script or a property draw in Unity. There are options later, but that's that bit. And just disable player movement for now. Don't worry about it working. By the end of the challenge, the cursors should change as they did before, but no click to move yet. So we're taking a step back to take a few steps forward. If this challenge seems too much, don't worry about it at all. It's a big change. We'll just integrate my changes. If you want to take on a good challenge of changing your architecture, go ahead, pause the video and do it now. Okay, welcome back. I wonder how you got on with that. That's a big chunk. Let me know in the discussions how you got on. The idea is that you need to get used to swapping and changing modules and dealing with architectural changes and generally just growing up in your coding a little bit and getting the confidence to do this stuff. If you couldn't do the challenge, well, then I've set the challenge too hard for the average person on the course. But I think it's doable if you thought about it and worked through it. So let's just basically go through one at a time. So the namespace layer cannot be found. So wherever we have under, for example, the cursor affordances, void on layer changed, layer new layer. Well, look, if we look in the camera Raycaster, the on layer change is now sending an integer new layer. All right, so no good registering a method here that first, and also by the way, the delegate list name has changed. Instead of what was it? It was on layer change. I've called it notify layer change observers just because I think it reads better. So we add to the layer change observers list this method on layer change, but it needs to be int new layer. All right, now let's stop that complaining completely because we are using the right delegate list name and we are adding a method that has the signature that's the same as in the Raycaster definition here. Okay. All right. So now we need to switch on the layers. Now we go get, for the moment, the layers straight from the list in Unity. Walkable is 8, enemy is 9, stiff is 10. We're just going to deal with walkable and enemy. So walkable is 8. Now, don't just put it in as a magic number. Let's serialize it and just specify it in the inspector. And again, we can improve upon this even more later. What this is doing is making it very explicit that in order to use the cursor affordance, it needs to know about certain layers. So we need to say walkable layer number, and I'm going to default it to 5 actually, because sorry, is it 5 or 8? 8, because I know it's 8, but we can change that in the inspector if we want. All right. So if you're using this in your game and you've got your layers set up differently, you're going to have the opportunity to customize it. Enemy layer number, and that is going to be 9, I believe. Just check it against Unity. That's fine. All right, so 8 and 9 are there, and as this script won't compile, I suspect these won't be available yet. No, they're not, but they're just going to be simple integer selections. So instead of saying case layer.walkable, we just say case walkable layer number. Now, being a switch statement, it wants a constant value that cannot change at runtime. So we can make that happen by typing const in front of all of these. That's fine. They just can't be changed at runtime. Then we've got one here, which is the enemy. Now, I'm actually going to ditch in this new architecture the whole concept of a raycast end stop, so we can get rid of that altogether. And then we just say the default is we don't know what cursor to show, or better than that, why don't you just show the question mark? If you don't know what cursor to show, show the unknown cursor. Okay, so case walkable layer, show walk, enemy, show target, otherwise show unknown. All right, that's pretty simple in cursor affordances. So we switch to an integer-based system. Now, what's next? All right, camera raycaster in playermovement.cs does not contain a definition for hit and no extension method of hit type. All right, so in the player movement here, we are asking the camera raycaster for the hit point, which it doesn't provide anymore. We're going for the other architecture. Now, the camera raycaster is sending as a delegate to the player movement, or will be, what the hit point is. So frankly, I said we're not going to be dealing with mouse movement. Let's just Control-K, Control-C, oops, Control-K, Control-C, comment all that stuff out of the player movement because we don't need player movement working. Let's move on. Okay. And that's it, actually. I think these are just warnings that things aren't used. So let's see how we get on now. Aha, we're back and working again. Okay, that's good news. Now, when I try and click, I'm going to get reference errors, but that's good. The only thing I would like to see happening here is that this cube that I've put on this stiff layer, I would like to think that the game doesn't know how to handle that. So let's just look at the camera raycaster. Size 2, layer enemy, layer walkable. Now, we'll talk about how this works in the next video, by the way. The camera raycaster now, this inspector is actually a custom editor, which is defined in the editor folder. So if you're wondering how the camera raycaster can give me a list of actual layers like this, when what we exposed in the camera raycaster script was a list of integers or an array of integers, then that's because we're using a custom script, all right? That's what's happening there. All I want to decide now is why does the system not give me a question mark when I'm over this cube here? Because this cube is on the stiff layer. I would expect that to say, well, actually, I don't know how to deal with that layer. So because the cursor affordance code should be saying, well, if it's walkable, then set that. If it's enemy, set that. Otherwise, I know what it is. It's because it's still considering walkable to be a higher priority layer. So the way that we would make stiff work was to say to the main camera's raycaster, okay, let's increase the number of layer priorities. Let's say that enemy is the top priority, but that dead enemy is the next highest priority, and then walkable is the lowest priority. So if we do that, then if we go over enemy, we get an enemy. If we go over the ground, we get that. But if we go over the cube, we get a question mark because it doesn't know what affordance to show for that. Now, there's two parts of this cube. That's the cube that's over the ground, it doesn't know how to handle, but where the white cube, the stiff, is over the enemy, is over the ground, it does know how to handle it because look at the priorities down in the inspector. Enemy is higher than stiff, so it doesn't care that stiff is over enemy. So if you were to click on an enemy that's hanging under a dead body like this, at this point you'll be selecting the enemy, at this point you'll be selecting the stiff. And excuse the word stiff, it's crazy. And the cool thing about this architecture now is because the camera raycaster is responsible for both announcing what the layer is and announcing what's being clicked on, all using the same code here in terms of the actual bit that goes and looks for the priorities, we now know that the layer of the thing that it sends as a hit out of the camera raycaster when we click is going to be the same as the layer that the cursor affordance is reading. So however many layers we get, we're not going to get confused and end up dealing with things inconsistently. Okay, the thing that changes the cursor, the delegate is using the same game object to get the layer as the game object that it actually sends across for clicking. So we make sure that everything's consistent. We also have this wonderful editor script that allows us to add layers all we like and just increase them in this list. The only thing we've done that makes it a little bit less pleasant is that somewhere we have, where was it? Is it in player movements? Somewhere we've just given ourselves, I'll tell you what, I'll look in my source controls, see what I've changed in this video. Yes, so remember that we tried to expose our walkable layer and enum layer. They had to be constant because the switch statement requires constants. And we could switch to if, but that's a bad idea. We want to use switch. It's the right thing. It's something that we know, is a single thing that we are switching on, and all of these different cases just depend on the value of new layer. So new layer does want to be constant, or the layer wants to be constant. We can't serialize a constant field, which is why at the moment you're not seeing in cursor affordance the ability to change the layer. So they're going to have to remain hard-coded here for the moment. We'll see when we get to custom inspectors like the camera Raycaster above. I know that looks like a normal Unity inspector, but it's only because we've made it look like one of those. We'll see when we get to custom inspectors how we can actually provide that facility. But for the moment, let's leave things as they are, and we have apparently very little advantage for what we've done. In fact, things are worse because we can't even move, but behind the scenes, wow, things are just stronger and better and much more robust, and the camera Raycaster is doing something much more reasonable about, which is broadcasting just changes of layer that you're hovering over and providing details of the thing that's been hit, and for convenience, the layer that's been hit when you click, so that only the camera Raycaster now needs to be dealing with a click. We're creating layers in our software to make things better. So in the next video, we'll take a look at that editor script, and then we'll get on to our player movement.